In section 7.3, we're going to take a look at first a moving cart. Well, I'm going to back this up in time, add a little ground here, and we're going to add our cart. And so this cart is empty, and it is moving to the right with a certain velocity v. So it has a certain momentum. P0 is mv. Now we know that because of the law of conservation of momentum, that P0 equals P. And that P refers to linear momentum, the momentum in a line. And so the line of movement is this line of movement. So the cart has momentum in that direction. As the cart moves from this area of no rain into an area where there is rain, it will start collecting the rain. Now, the rain itself does have momentum, but its linear momentum is perpendicular to the linear momentum of the cart. So it has zero momentum. The rain has zero momentum horizontally. But since it falls inside that cart and gets caught, it will take momentum from the cart. So what is happening afterward, after it moves into the rain, and then as the rain collects, we have P0 as mv, and afterward we have our momentum at any instant in time, which will be equal to the mass and the velocity. Well, initially the mass was the cart, but the mass is now, this P is P0, the mass is now increasing. But the momentum stays the same. So that means the velocity must decrease. So as this cart gets pushed along its track and it's raining on it, it's going to gain mass. All the while it gains mass, the mass of the cart system, which is the mass of the rain and the water from the rain and the cart, the total mass is going to increase, and that momentum is now shared. So V must decrease. And so that's what happens with a horizontal cart. Now let us take that to another step further. Let's suppose we have this gravel conveyor belt, and the gravel is not yet being released. So here is a hopper of gravel, and there's like a little handle on it. It's not opened yet. And so the conveyor belt is moving, and let's suppose the wheels are frictionless. And the system is set in motion, and so every instant and every location on the belt is going to have a constant linear momentum to the right as it moves around. So there is some initial momentum, P0, that is equal to the mass times the velocity. Well, after the sand starts to be dropped, the momentum is still the same. The initial momentum equals the instantaneous momentum is going to be equal to the mass times the velocity. So what happens is the mass increases. The mass increases because the sand is being added to it. So the velocity would decrease. So dumping this sand on it would have the same effect as the rain in the cart. It would slow it down over time. So what we need is a motor to make up for the lost momentum. And that the motor does work to increase the kinetic energy of the sand. Because the kinetic energy was zero, it gives it momentum, it gives it kinetic energy. So the work from the motor goes into increasing the kinetic energy of the sand. And so that is our example of moving cars and conveyors. In our next installment, we are going to look at safety features that we encounter every single day.